Today we are going to learn reaction in a moving lift. Reaction, reaction in a moving lift. Reaction in a moving lift. So everybody must have felt this that when you are in a lift and you press the button and the lift is going up, then suddenly the lift starts to go up. You feel a gain in your weight, increase in your weight, right? And when you are coming down a lift and suddenly the lift stops, right? You feel that you have a decrease in your weight. Have you felt this? Or better in fairs where you have the Ferris wheel or the Columbus boat, where when you go up, you feel a weight increase in weight, and when you come down, you feel a decrease in weight, right? So what is the reason behind it and how to quantify it? So let us draw a lift and then we will see what happens. So if this is a lift, right, and there is a box on the lift, this box is on the lift. So suppose this box is in the lift, right? So this box, weight is acting downwards, right? Weight is acting downwards and a reaction force is acting upwards. This block is placed on the floor of the lift, right? For your benefit, I am just drawing the block above the lift, but actually this block is on the floor of the lift. Understood? So this is W, means the mass of the lift acting downwards, right? And this reaction force which the lift gives, better to take it as R. Reaction force the lift gives on the block is R. It is acting upwards, right? And the lift is moving upwards. See, I am drawing the lift moving upwards, right? So lift moving upwards. So if you do the force, this is known as free body diagram. This thing what I am doing is known as free body diagram. Free body diagram. Free body diagram. In free body diagram, the summation of the forces is zero. The summation of the forces is zero, right? Summation of the forces in the positive x-axis is equal to the summation of forces in the negative x-axis, and the summation of forces in the positive y-axis is equal to the summation of forces in the negative y-axis, right? So in this free body diagram, what we are getting that this actually is the resultant acceleration. This is the actual resultant acceleration. So which force is greater? R is greater because the lift is moving up, right? So R is greater, right? So I can write R minus mg is equal to m into acceleration, is equal to m into acceleration. From here I can write capital R is equal to m g plus a, right? So this R is actually the weight you are feeling. This R is actually the weight you are feeling. This reaction is actually the weight you are feeling. If you place a weighing machine, right? If you place a weighing machine or a spring balance here, right? So you will see that spring balance will not show mg, but it will show R. So this, your weight was mg. Now it has become mg plus a. So you are feeling an increase in weight. So whenever the lift goes up, you feel an increase in weight. Understood? You feel an increase in weight. So now if the lift comes down, right, and the force acceleration is again a, so when the lift is coming down, then what happens? Mg is greater, mg minus r is equal to m into a. So from here capital R is equal to m g minus a, mg minus a, which means your weight has now decreased. Earlier it was mg and now it is m g minus a. So when the lift comes down, You feel a loss in weight. You feel a loss in weight. So now if I tell you that the lift acceleration of the lift is equal to g, which means that somebody has cut the wire of the lift and the lift is falling freely, and the lift is falling freely. So A becomes equal to G. Acceleration of the lift is equal to acceleration due to gravity. So what happens? R becomes 0, which means you will feel weightless. You will feel weightless. Understood? You will
Hmm.
feel weightless. Now what happens if the acceleration of the lift becomes greater than acceleration due to gravity? What happens? Whenever the, then this what, R will become negative, right? R will become,
Negative.
R will become negative, na?
Hmm.
So it will be M A minus G. M A minus G. What happens? Then the man gets detached from the floor, right?
Hmm.
The man gets detached from the floor of the lift, right? And he will continue to rise up till his head touches the ceiling of the lift, right? And he will continue to move in that fashion until and unless the acceleration due to gravity becomes equal to or less than the acceleration acceleration of the lift becomes less than or equal to the acceleration due to gravity. Understood?
Sure.
Understood? So this is how a reaction in a lift works. Okay.